Hi, this is problem B, apples in boxes. So you can read the problem statement here, the story here. I'll tell you what the problem statement is. You are given, there are two players actually, Tom and Jerry. Okay, and they're given an array A, let's say, and the array elements are these. These are elements, n elements, and these are all are positive numbers. Okay, so the player, each of the player can perform a task that he or she pick one of the element and it can decrement by one. Okay, so and the player can lose in two scenarios. Like after performing his or her task, if all of the uh, elements becomes zero, exhausts, then player can lose. Or after performing his task, if the difference between max and min element is greater than a number k and the k is given, so the player has performed this task, and after that, if the difference between max and min is greater than k, then the player loses. So let's understand the flow with an example. Let's take this example, 3 1 2 1 2. Okay, this is n, this is k, and this is the array, and the first turn is of Tom. Okay, so Tom have choice that he can pick any of the element and decrement by one. Let's say uh, currently max minus min is 1, right? 2 minus 1, which is greater than equals to k, which is 1. Okay, and that is fine. What Tom can do is, let's say he picks 1. He picks this one and decrement it by 1. So 1 1 2. So still max minus min is 2 minus 1 is equals to 1, which is again fine. So now in this way, and then let's say in the second turn, Jerry picks, let's say, this element. So it becomes 0, right? So now max minus min becomes 2 minus 0, which is 2, which is greater than k. So Jerry will lose if he picks this element. Okay. So this is the flow. Uh, this is the flow. Now, for the given array, if both players play optimally, we have to decide who will be the winner. So let's see the scenarios, different scenarios through which we can decide the winner. So see, there are two cases, I will say. Okay, for the given k, there are two cases. The case one and the case one and the case two. Okay, so the case one is, let's say we have this array. Okay, and I have a max minus min. Let's say it is x. Okay, so in case one, I will have that. Okay, max minus min x is already greater than k, and in case 2 I'll have max minus min is less than equals to k. Okay, so why I have included equality in this case is, this is the breaking point, right? It should not be greater than k. If it is greater than k, then it's a problem, right? So these are the two cases. So let's solve this case first. So if it is already greater than k, then uh, we know that player can move at least one move. Player can play at least one move. Okay, so if max is greater than equals to k, let's say I have this array 8 5 3 1. Okay, and I have k equals to, let's say, 4. So let's say k equals to 4. Okay, so the max minus min is what? It is 7, right? So Tom at least can play one move. Okay, and after that move, if max minus min is still greater than k, then he will lose, right? So what will be the best strategy of Tom? And the given array can be in any order. I have sorted this. Okay, what will be the Tom's best strategy? So see, max he have to do max minus min. Okay, so the Tom's strategy would be to keep this to make this less than equals to k. In what way he can make this less than equals to k? He will try to decrease the max value. Then only he will decrease this value, total value. Okay, so he will try to decrement the max value. Let's say he makes this 7 5 3 1. Okay, and then still if max minus min is greater than k, then we can say that okay, Jerry will be the winner, right? And there is a special case here. Let's say, let's take another example. Let's say we have, okay, let's say the array is 5 5 and 3 2. Okay, and let's say and in this case, again, Tom will decrement the max value, right? And Tom will decrement the max, and this case is like the max value is repeated. So Tom will decrement the max value, and the max value would be 4 5 3 2. So please note that max value is not still the first one. The max value would be the second one, because max value is repeated. So you will check. So while checking this max minus min, whether it is greater than equals to k or not, greater than k or not. So what you will check is, if you have sorted this in decreasing order, then you will check that okay, the max of array of 0 and array of 1 minus array of n minus 1, the minimum element, whether this value is still greater than or equals to or not, right? After decrement, after making one decrement, okay, of the max value, then you will check this, okay? And the so this will be the case, this will be case one, okay, where x is already greater than max minus min is already greater than k. Let's solve for case two. Okay, that is max minus min is less than equals to k. Okay, let's say example 21, 18, then 17 and 16, and we have k is equals to 23. Okay, so you can see max minus min is less than equals to k. Okay, so again, player will choose the optimal strategy. Okay, so he will try to uh, he will try to not disturb the max minus min. And how he can do this? See, max minus min is decided by these two elements. Okay, I have sorted this in descending order. Okay, by the way, and the array and the given array can be in any order. So the max minus min element is decided by these two elements. So he will try not to disturb these two elements, and he will try to choose the numbers in between, because if you choose the numbers in between, still the max minus min will not change. Okay, so but there is a limit up to what up to which the number can be changed. For example, this can be Tom, initially the turn is Tom, right? So Tom can decrement to 17. Still the max minus min is less than equals to k. Okay, and again Jerry can decrement it to 16. So but note that after that it cannot be decremented, because after that the maximum minus min will change, and this will not be the optimal strategy. Okay, so up to the number which is equals to the min element, any of the elements in between can be decremented. Okay, this will be the optimal strategy for the player. And again, same for other elements as well. This can be decremented up to 16. So eventually, if I have these many numbers ai up to an, all of the numbers in between can be decremented up to the last, which is equals to the last element, and it is the minimum element. Okay, so eventually in this example, the array will turn to 21, 16, 16, 16, right? So, and again, please note that max minus min is still k, still less than equals to k. And even if I decrement this value to 16, again, the max minus min is still 16. Okay, and I have k is equals to 23, right? So, and after that, if I try to decrement this value again, even if I go to 0, uh, max minus will not go beyond 23. Okay, there can be cases in which, let's say, after decrementing, I will in some other example, I had these numbers. Okay, 98, 98, and case still 23. So there is a limit up to which you can decrement this, right? You can decrement this up to 75, right? So up to 75 you can decrement this, and after that you will decrement this value. So all of the elements will become 75, right? And again, still you will try again this to decrement this, and again there is a limit such that the difference does not go beyond 23. Eventually you will reach a point that all of those elements will become 0. Okay, so the point is, you are utilizing all of the elements. Okay, all of the elements in the end will get exhausted. So basically, uh, all each players will have their turn for each of the numbers. Okay, all numbers will get exhausted. So you can just say that if you can just calculate the sum of the array. Okay, sum of the array. Okay, and you will say, see, first turn is Tom, right? So, and second turn is Jerry. Okay, and third turn is again Tom, and fourth term is again Jerry. Okay, so if at any point the array, since we are utilizing all of the elements, if at any point the array exhausts, that pair will lose, right? Okay, so if it is this even turn and the array exhausts, then Jerry loses. And if it is the odd turn and if array exhausts, then Tom loses. Okay, so in case one, you can just have that check, and in case two, you can just calculate the sum of the array, uh, and you can just check whether it is odd or even. Okay, let's see the code. You will have a better understanding. So this is the given array. I just sorted it, and I have solved the case one here. Okay, I have taken the uh, max of the elements, and n minus 2, 2 and n minus 1, minus 1. Okay, because 1 has to be decremented, and if it is greater than k, then I will return Jerry. Okay, because Tom will have to Tom will can move Tom can play at least one move. Okay, and after that, I have made the sum of total. This is the case 2, right? So after that, I have just calculated the sum, and if it is odd, I will return Tom, and if it is even, I will return Jerry. Okay. So if you have any doubts, you can comment in the comment section. I will check that. I hope this was helpful. Thank you.